Hello everyone.
Hello.
I hope you are feeling refreshed after the coffee break. It's coming towards the end of a long day. Okay. So welcome to all of you to our presentation, Single Source Publishing, Bury the Hatchet with DITA-OT. We use DITA-OT in many of our flows in Unix and in Windows environment. For example, we use DITA-OT for content filtering, we use DITA-OT for flattening of key defs and printing multiple PDFs and HTML. In today's presentation, we'll focus upon three things. One, why we felt that single sourcing is the best option for our product documentation needs. Number two, some of the challenges that we came across when we implemented single source publishing. And number three, how DITA-OT turned out to be the most elegant solution for all our single source publishing issues and challenges that we faced. I'm sure by end of this presentation, you will have a fair amount of idea of the elements of the DITA-OT project file and how it would streamline your workflows and provide us an elegant solution to all your challenges. But before we start talking about DITA-OT, I would like to give you a background of the kind of documents that we handle, the products that our organization provides. We work for Synopsys. For past 4 decades, Synopsys has provided efficient technology to facilitate the development of advanced chips. Synopsys is a leader in electronic design, EDA, tools and services. Synopsys has the broadest portfolio of interface, foundation, security and processor IPs. Synopsys is a pioneer in electronic solution services and AI-powered EDA. Synopsys powers an era of pervasive intelligence. The pace of work at Synopsys or the pace of innovation at Synopsys is phenomenal because Synopsys drives the latest technology trends like high-performance computing, IoT, AI, ML, and whatnot. We provide documents for all the Synopsys IPs, for all the Synopsys interface IPs to be more specific. For example, USB, PCIe, Ethernet, you name it all. I'm sure each electronic device that is present in this room uses at least one Synopsys IP. And in addition to that, we also provide automotive-grade variants of these IPs. We provide the AMBA interface also, which stitches together all these IPs on a system on chip. IPs are actually building blocks that system designers or chip designers use to create their own products. IPs are quite complex. To understand the complexity of our documents, it is important to understand how the IPs evolve. I'll give example of 2 of the most complicated IPs that we handle. There's a lot of jargon on this slide. We'll not go through all of them. But the point that I want to stress over here is that over past 20 years, the PCI IP has created 7 generations. We provide documents for all these 7 generations. The challenge that we have with PCI IP is that we have one document. The PCI, all the generations of PCIs are backward compatible. So we have one document that provides information about all the 7 generations of PCIe. So at one end of the spectrum, we have the PCI IP, and at the other end, we have the DDR IP. As by specification, DDR has created categories to cater to different marketing needs. So DDR is one of the products that we handle which has the maximum number of variants. For each release of DDR, we generate documents for more than 20 variants. As the IPs grow, the complexity of our documentation also grows. So we start simple. Our documentation set generally consists of 4 to 5 PDFs, which is the data book, the reference manual, the user guide, the installation guide, the release notes, and a couple of more documents. During nascent phase of development or during the inception of the IP, we provide mainly the data book and the reference manual, which is around 100 pages. As the IP matures and we provide the entire documentation set, we generate around 4 to 5 PDFs for each IP, totaling around 1,000 pages. As the IPs become, as more and more variants get added to the IP, the number of PDFs also increase. So we end up generating around 4,000 PDFs. But for an advanced IP or a highly matured IP, we generate around 20 to 40 PDFs. And for one release, we end up generating around 40,000 pages. I'm talking in terms of PDFs. We also generate the HTML output for the IPs. So to sum it all the IPs fit into this figure or this diagram that we have put together. There is one product or one IP, and we have multiple variants. It can be one or more than one variants. At one end, like I said, we have PCIe where we might have 1 or 2 variants, but the number of pages remain the same. It's around more than 40,000. At the other end, we have DDR, which has more than 20 variants, and we generate documents and provide documents for all the variants. We have tried multiple things to maintain the source code of our documents, the source files of our document. But we realized that single sourcing is the ideal solution for all our documentation needs. And the reasons are obvious. It facilitates content reuse. We work, like I said, our IPs are complex and we don't have the luxury of time. Our releases are quite short-paced. So we have a team of writers who handle the IP documents. One lead and a couple of more writers to assess the documentation generation. So it becomes very easy, with single sourcing, it becomes very easy for the lead to validate the content, to ensure that the information is accurate, because accuracy is of utmost importance to the IP documentation. It's also easy for the lead to validate whether all the information is correct. To give you an example, I have talked in previous slides about the DDR IP and the documents that we support for it. So we generate multiple variants of the DDR IP. There is some content which is common across the multiple variants of DDR, and we cherry pick some of the features that are used or that are specific to a particular variant of DDR. Our content is heavily profiled. We use a combination of DITA-OT files and key refs to generate documents for different variants of the DDR IP. Now that we have understood the complexity of our documents, I'll hand over the baton to my colleague Snehal, who will talk about the single source challenging.
Hi all. So we were in our own fairy tale. Everything was going smooth. So where did we hit our showstoppers? That is our critical blockers. So I'll just walk you through our challenges. Coming to our first challenge was that from our data map we were generating multiple outputs, but in Oxygen we saw that the output file names were taken from the input data map file name. So we had to generate multiple variants, but they were getting generated with the same name. So how do we overcome that? Second challenge was which DITA-OT file to use. Every time we applied a transformation, we had to select a DITA-OT file, and we had a number of DITA-OT files for our number of variants. So to ensure the correct DITA-OT file was picked with the correct input data map was a challenge for us. Coming to our final challenge was that we were generating multiple PDFs through the releases repeatedly. Now to ensure that you are selecting correct input data map, correct DITA-OT files, and generating output file names correctly with unique names was a challenge for us. So then came our most elegant solution, that is our own DITA-OT project. So now I will show you our DITA-OT project file and how we tackled our problems. So here is our DITA-OT project file snapshots. The first image shows the context file. Context file, you may wonder what is this context. The context is just a combination of input data map file path and the corresponding data-val file path. Coming to the second part is publication file. Publication file, we had multiple publication scenarios with multiple templates. So we had unique transformation parameters which we were defining in this publication file. Going ahead, we had a deliverables file where we were defining the context and publication file. So if you see here in the deliverable element, we have context where we are defining the input data map and data-val file. The output element is used to set the location of output PDF. We select the publication used for this particular variant, and we could also set the output file name. Now let's go to the challenges of single sourcing, which we could troubleshoot using the DITA-OT solution. So first challenge was the output file name setting, if you remember. So before DITA-OT, I would start with an example of DDR controller data book. So here if you see, for variants like DDR5, 4 and 3, we have same name for the output PDF. So here we do not have any output differentiation, and every time the writer, before proceeding for the new variant file generation, he had to manually rename the file. So this was becoming very error prone for us. So after using the DITA-OT, we could define the file name in the deliverables file itself. So now we could get the different file names, different output file names for all the variants like DDR5, DDR4 and DDR3. This gave us clear output differentiation. Coming to our second challenge, that was data-val selection. So as I said before, we were using data-vals for filtering our data maps. So here if you see, I am using the same example of DDR data book, where I am using 3 data-val files for DDR5, 4 and 3. So picking here I am taking a smaller set, so yeah, I can do it correctly. But we have over 20 variants, which was error prone for us, and we could not validate our data map against the data-val files. But after the use of DITA-OT, we could preset our context with the said input data map and the data-val files. So the manual intervention reduced, and we could also validate our data maps with respect to the corresponding data-val files. Now coming to our final challenge, that is generation of multiple outputs. For each release, we were giving multiple deliverables. Let's say a writer had to generate 10 documents for each release. So he had to ensure that he was picking correct data map with correct file name, data-val, and setting the correct output name. So that became easier with the help of deliverable file, where we could define the output file name in the deliverable element itself, and we could generate one output at a time or all the outputs at a time. Deliverable file gave us total control of the system to define the inputs and variants at a time. So now I would like to show you a short demo of our system. So here is our directory structure, where we have folders of data files like for different document types, like for application notes, user guide, data book, install guide and so on. And all the PDFs we collect at the PDFs folder. For DITA-OT project file, we have created a project folder. So I will just go inside the project folder now. This project folder has one context file and grouping of different deliverables for the DDR. So let's go to the DDR5 secure IP group for checking the deliverable file structure. So here if you see in this deliverable file, we are including the context file, the publication file, and in deliverable element for DDR5 secure install guide, we are referring to a context. So this context here, inside this we are defining the install guide data map and the DDR5 secure data-val file. Apart from this, we are also providing the output location, the publication scenario and name of the output file. I would like to quote here that we have progressed as and when DITA-OT was progressing. Like before DITA-OT 4, this was the structure of DITA deliverable element, where we had to define the publication in each deliverable element. But now if you see, it's a hardly 4-liner where we can accomplish our dream. And yeah, we could also generate outputs using this transformation button here. So we could generate one output at a time or all the outputs at a time. So yeah, that's it about me. Any questions? Yeah.
So this is very interesting. I'm curious how much time you spend maintaining the project files.
So the variants are defined at the early stage of IP development, and if they are added at incremental stage, we just have to add the context and corresponding deliverables. So maintenance is very easy.
It's like one time we have to work on the DITA-OT project files, and then we can use it for every release.
Okay, so basically once you've created it,
Yes.
it's stable over
It's
time.
stable.
Yeah.
Yes.
And that's because your publications basically reflect your products, and your products, once you've got a product, it's there forever.
Yes.
Yeah, you can say that.
Yeah. Thank you.
Okay, thank you
Thanks
so
a lot.
much for listening to us.
Sorry, I just wondered how do you manage the storage
Okay.
issue, because it looks like you're working locally there.
No, so right now for the demo we are opening the project file locally, but we use Perforce as a versioning control system. So all our files are submitted to the Perforce depot so that the writers across the team can access it.
Okay. So thank you Oxygen and DITA-OT for helping us out through our journey. Yeah.
And DITA-OT 4 was gave us we wanted to maintain one publication file, because the transformation scenarios and the parameters that we use across our across the groups within our team are the same. So with DITA-OT, we could maintain one publication file, which is common for all the projects that we handle. So it was like, it became a very, the rate of, or the amount of error that could happen had reduced to minimal.
So final thank you.